Okay, so Math 30-2s, here's the last worksheet of the year. So we are going to use logarithms to do regressions here. So let me just get my calculator out, this one right here. And we are going to do this using the TI calculator this time. You can use Desmos as well, works the same way. Whichever you're more comfortable with, I'm just going to use this. So, I'm going to try to get this so I can see all the questions. Cool. All right, so now, did we see this question already? Where did I see this? This was in our notes, wasn't it? Oh, there's just different questions down here. So we're going to use the same regression. And this one here, yeah, this is a new one. This is we've seen this before, but let's try it again. So we're going to go. Actually, first of all, I'm just going to get rid of everything in my tables because I might have some stuff there. So I'm going to go second plus. Go clear all lists here. Hit enter, hit done. Hit enter, enter a couple times until it says done. Now I'm going to go stat edit. So make sure these are clear. All right, and then I'm going to type in my numbers here. 1, enter 2, enter 3, enter 4, enter 5. And then we're going to go over here and just make sure everything lines up when I put these in. 6, 5, 13, 15, 16.5. Maybe this is different data. It looked familiar, but maybe it is different. Just double check. Okay. Okay, making sure everything lines up. So I got 11 on both sides. Perfect. Now we are going to look at this, the plot of this. So I'm going to go y is equal to, I got some stuff here. I'm just going to clear those out. Go to plot and turn that on. Then go zoom stat, which I believe is number 9. Let me just double check. Yep. Oh yeah, this is different data. Before, these data points here were a little bit lower. But does follow this typical logarithmic trend. We're kind of slowing down just a bit. Okay? So I want to determine the logarithmic regression of this data. So I'm going to go stat, calc, and then I'm going to go LEN. So I don't know where the LN one here. Let's see if we can find it. Not the line, but the LN, the natural log regression. So LN. Enter, enter. I want to store this equation so I can see if it matches up nicely. So I'm going to go, now if you don't have one of these ones, you can go alpha trace. You may have to go vars, hit vars, go over to y vars, go to function there, and hit number 1. Okay, so there's my logarithmic regression. So my equation is going to be y. No, this is y, this is x here. So y is equal to a, and this is a 6.099, okay, plus b, which is 6.108, the natural log of x. There's my equation. According to your regression, what is the height of the tree when they are 1.5 years old, so 1.5? So that's what they want to know, when x, because x is the age, so 1.5. So I can put it into the equation, or I can go to my graph, and hopefully my graph shows it. Yeah, pretty good trend there. Looks pretty good. It's kind of losing at the end there, but that's fine. So I can go trace. And now watch at the top here. You don't want these to be the points. You want them to be the equation that we have here. So go up and down here until you get to the equation. And since you're in the trace, you're going to hit 1.5. So I'll move the cursor to 1.5 on the graph, and we get y to be to the nearest tenth. So that's 1 decimal place, 8.6 feet. There you go. Now, if I put into my equation, I probably should get something similar. Let's double check here. So 6.099 plus 6.108 natural log of 1.5. Let's see. 8.6, yeah, works out the same way. A little bit off on the other digits, but that's fine. What is the predictive height of a tree that is 20 years of age? So I could do the same thing in here. I can go just change the 1.5 to 20. Okay, so I want x to be 20. So I could get 20.4. Or I can go to my graph. Now the thing is, if I try to go to my graph, and I go trace, and I try to find 20, it's going to be beyond my graph. Like it's beyond my domain. I'm always concerned about the domain. Never really concerned about the range. If I can at least see the domain, then I should be able to find the answer. So if I go to my window, change my x, because I want my x to be 20. I can change it right to 20 if I wanted to. There's my graph. I can't see it over here because 20 is right here. It's going to be off the graph. But I can go trace. Hit 20. And now it works out here. So I get 20.4 like we had before. I think that's what the answer we got before was. Let's see. Second mode. Yeah, 20.4. If the average height of the tree is 10 feet, what is the age to the nearest 10th? Okay, so I want to know when y is 10 feet, what is x? Okay, so you could try to solve this algebraically, but we have the graph for a reason. So I'm going to go y is equal to, I'm going to put a 10 in there on the second equation. Should we show, there's a nice little intersection there. So you're going to go second trace, intersect. Now you don't have to worry about the points here because the intersect function only works with lines. So it's pretty smart when it does that. As soon as it says intersection, you got an answer. So this is going to be 1 point to the nearest 10th again. I don't know why that's italicized. There you go. Perfect. Yeah. 1.9 years. Cool. There we go. Oh, we have one more. Almost quit here. Okay. Okay, so I'm going to go and put this new data in. So I can go into the chart, but I see, oh, I have stuff here. If I just go up to L1, hit clear, enter, and I go over to L2, make sure you highlight the top there, go clear, enter. You can clear the list right here. You could start off at zeros and go all the way to like 110 here. That's what it specifies here. They say 1 is 1900. Okay. We could do it that way. But problem is if I do it that way, then you have to remember what number is what. Like X is the number of years, where 1 is 1900. Why do it that way when you could just put in the numbers as is? If you put the numbers as is, your regression is going to be a little bit more ugly. That's fine, right? But I'll give you the answers you need, right? Or if you put in the 1, 2, 3, 4, 5, 6, 7, you can still get the answers, but then you just have to realize, okay, what is 2030? 2030 is 129, I think. Yeah, maybe. Oh, they go by decades here, so maybe 29, the 29th decade, right? So that's just kind of a guess game. Well, not really a guess game, but there is some logic behind the numbers. Okay, so we could do it either way. It's up to you. I'm going to do it the way they say here in decades. If I call this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Actually, this is the 14th after that point. Yeah. So this would be X is equal to 14 for that year. Okay. It's a little bit tricky to do, but let's do it. 1. Oh, what do I type here? That's weird. I was going to type in my calculator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. Okay. 47.3, 50, 54.1, 59.7, 62.9, 68.2, 69.7, 70.8, 73, 7, 75.4, 76.8, 78.7. Perfect. Okay, everything lines up there. Zoom stat. There's my line. It kind of almost looked kind of straight, but that's fine. We're going to do a regression, a logarithmic regression here. So calc lin regression, so number 9 here. I'm going to store this equation into 1. So alpha trace, get that again. R squared's a bit off there, but that's fine. So my equation here, so if I'm using the 1, 2, 3, 4, 5, 6 like that, my equation ends up being, this works for me, y is equal to a, which is 42 point, I don't know, it's 5.3, whatever, plus b, which is 13.86, natural log of x. So there's my equation. Okay. Now, we already kind of went through this, like if 2020 is 13, 2030 is 14, so my x is 14. So I'm going to go back to my graph here. Follows the trend pretty good. And then I'm just going to go trace and then find 14 on here. So 14 might be off my graph. Let's go to my window. Only goes to 13, so I got to go to 14 at least. Let's go a bit higher. Let's go 20. Now I can go trace 14. So I get 10. Okay. Well, that makes sense for me. How do I get 10? What am I tracing here? Oh, I might have other equations here. Oh, I do. I have this other equation I need to get rid of. Whoops. Okay, now I can go back to the graph here. Hit trace. That's better. Now this equation on the top matches what it needs to be. What I need, 14. There you go, 79. Nope. 79 point, I don't know if it says anything about decimal places. Everything is one decimal place, so 79.1 years. Based on this model, when would the first life expectancy of American first be above 83? So I'm going to hit y is equal to, I'm going to put an 83 there. So this is my y value. So they're saying that, remember this is your x, this is your y. We're trying to find x, okay? So let's put that there. Let's go graph. Oh, I can see the intersection, that's good. So this is going to be easy. Don't have to do anything with my window. Ends up being 18, 19. Let's go 19 because 18.5 rounds up to 19. But what does 19 represent? Okay, so this represents the year 20. What does it represent? 2015 is, this is why I didn't like this number. Okay, so I'm just going to go over here and write this on the side. So 14 is 2030. 15, 16, 17, 18, 19, 60, 70, 80. So the year 2080. Right? Look at the year 2080. There we go. Yeah, so work on your assignments. And then study up for the final test here for logs. And I'll see you then, I guess. Bye.